Before we get started, I want to talk briefly about the code of conduct. This is a formalization of the great culture we have here at Awesome.js. You can find it at awesomejavascript.com/awesomejs-code-of-conduct. The short version is that we're dedicated to providing a harassment-free meetup experience for everyone, regardless of gender, sexual orientation, disability, physical appearance, body size, race, or religion. We don't tolerate harassment of meetup participants in any form. Sexual language and imagery is not appropriate for any meetup venue, including talks, workshops, parties, Twitter, and other online media. Meetup participants violating these rules may be sanctioned or expelled from the meetup without refund at the discretion of the meetup organizer. So if you run into any trouble around this, you can come and talk to me. You can also reach out on Twitter at JavaScript or our Slack, which you can reach through our website. So, here's how tonight's going to go. We're going to give a moment for our gracious sponsors, Indeed Prime, to come and talk. So, Ingrid, if you would like to come up and speak.
Thank you very much. Hey everyone, my name is Ingrid. I'm a career coach at Indeed Prime. You've most likely heard of Indeed, largest job site in the world, but I work exclusively on the product side of the house on Indeed Prime. We specifically cater to tech talent. So we match companies with candidates for jobs that they're currently looking for. We like to think of it as the dating website for jobs. So myself as a career coach, I work with candidates like software engineers to help them through their job search, not only on Indeed Prime, but in general. So I conduct resume reviews, do mock interviews with you, do salary negotiation, regardless if you take a position on Indeed Prime or not. We're located in Austin, Texas, but we serve major core markets across the United States: San Francisco, Chicago, New York, anywhere you can possibly imagine. So if any of you or your friends are looking for a job, please come and find me. I'm more than happy to go through exactly kind of how Prime works, but just kind of give you a brief overview of what to expect if you are in the job market and looking for a new opportunity. Once you create a profile on Indeed Prime, companies are able to find you and reach out to you directly with positions that they have open and available. So it's a little bit different than the traditional job search where you spam out your resume to a million jobs and hope to hear back from a recruiter. Once you're on the Indeed Prime platform, companies are able to search for you. So you can kind of take a more passive approach into your job seeking. You're also paired with a career coach like myself. Me or my colleagues will help you through the entire process of finding a job up until the very end. So again, feel free to come up and find me if you need more information. I'm happy to direct you in any way I can. If you need more information, you can go to indeed.com/prime and just go through any of the information that you were seeking there. So thank you very much. I hope you enjoyed tonight. If you have any questions, don't hesitate to reach out to me.
Thank you. Let's also give a quick round of applause for ScribeFast, our gracious hosts. No, little dude, something, wherever they are. This place, these people, they're lovely. Thank you very much. And so, without further ado, we'll introduce Marie, and after she speaks, we'll do some Q&A, and then when we wrap up, we'll head over to Locker Street Bar, getting out afterwards. Everybody's actually doing that. But let's have a hand for Marie.
How is everyone tonight? Yeah. While I'm setting up, instead of awkwardly watching me, you can awkwardly move to the really comfortable chairs at the front. I can verify that the couches are great. Is the mic on? Okay, we're good with the sound. Give y'all 3 more seconds to get cozy. And maybe in those seconds, we'll get some pictures. Welcome to an eventful evening with your host, me, Marie Chatfield. I am at Marie Chatfield on Twitter. If you tweet, you can tweet me there. I'll also include my handle on all the slides, so you can source me if you take pictures. So in case you haven't been able to tell yet, this is me, along with my cardboard cutouts of myself, Tall Marie and Small Marie. They're here. Small Marie has gone on some adventures without me, She has her own Twitter account, actually, that I definitely do not run. But even though I am originally from Houston, the three of us have spent the last 3 years in San Francisco. And about a month ago, we all moved to Austin, where I am now working as a software engineer at Pingboard, and Tom Murray lurks in the corner scaring all of my new coworkers, which I really appreciate. Thanks, Ryan. By the way, Pingboard, where we build beautiful org charts that help people understand their workplaces, is hiring another front-end engineer. So if you're interested, you can go to pingboard.com/careers or chat with me or Ryan afterwards. But in a previous life, when I was working at a different company that was mostly using Ember, I ended up running into this really tricky bug at work that had to do with the way that Ember.js was working and handling events. And so, as one does, I made a flowchart, and then I turned that into a blog post, and then I turned that into a conference talk. And now I'm here tonight to talk to you about events even more, at the risk of becoming that events lady. And that's because events are important. Without them, our websites are really beautiful but really boring pages that don't do anything when you interact with them. So tonight, we are going to cover, in our first act, where do events come from. We're going to be talking about the DOM standard and how it defines what events are, as well as how to listen for events. Then we'll have a brief GIF intermission, where you can take a break with your eyes or look at one of my favorite GIFs of all time. And then in Act 2, we're going to come back and talk about where do events go, talking about event propagation, things like bubble versus capture, delegated events, all that fun stuff. So before we get started with Act 1, I would just like you to ask to please keep all questions, comments, observations, concerns, and objections until the very end of the talk, because I have a lot of content that I'm trying to squeeze into 30 minutes, but I will give you a chance to ask me any questions at the end. So let's get started. Where do events come from? Events come from the DOM. The DOM is the Document Object Model, which is basically an API that describes how web pages work. So browsers use the DOM in order to actually give us the web as we normally think about it. So for example, this is how we go from a pretty static HTML site like page that just has a whole bunch of text inside of it into a DOM tree. This is a data structure that browsers use, and it's this hierarchical data structure. So there's all these different nodes that each have parents and might have some children. That defines every single thing that the user actually sees in the browser. So everything you see in the browser does actually have some reference in that DOM tree data structure, as well as a whole bunch of stuff that you don't actually see, but that still needs to be kept track of. So you can think of the HTML and DOM standards essentially as rules or guidelines that tell you things like how do you parse HTML text content into actual DOM nodes. Things like what are some different elements that you can use in the DOM and what do they do? So for example, what is an input? What does an input with a type checkbox look like? What does one with the type radio look like? And how are those different? All of that is defined in the HTML and DOM standards. There's also things like different JavaScript objects and functions that the browser should provide to you so that you can interact with the browser and with the DOM. So if, for example, you've ever tried to console.log something when you were running in Node, which is JavaScript not in the browser, and you realize that console wasn't defined, that's because console doesn't actually come from JavaScript, the language. That comes from the browser based on DOM and HTML standards. And there's a whole bunch of other stuff that are in these standards. They're really long and very technical, and they're really mostly intended for people that are writing browsers to read them in order to actually implement everything that we're expecting to use as app developers. So you can think of the HTML that you're writing for your website as like house plans, like architecture plans. You can send those off to a browser. The browser will read all of the DOM standards and use that in order to know how to interpret your plans and build the DOM. And in theory, if you send the exact same HTML off to a different browser, it will read the same standards and build mostly the same house. But that's a whole other talk. It doesn't end here though, because you also have people and scripts and anything else that you're writing interacting with the DOM as people are doing different things like submitting forms. And so it can end up actually modifying the DOM, or if you're doing single page apps and a lot of client-side routing, your entire DOM might get replaced with a whole other page, even though it was loaded from the same HTML file. But all of this modification that's going on is happening using different events and APIs that are defined by those DOM and HTML standards. So the way that we handle events and things like interactions with the users is with the DOM event API. This is part of the DOM standard. And it's this API that just describes that something has happened on the page and gives you an opportunity to react to it. So it's things like clicks and keypresses and touch events and form submissions and pretty much anything interesting that might ever happen in the lifecycle of your application. So, for example, we can say that if we have a start the party button, we expect that if we click on it, we will start the party. How do we do this? One of the most straightforward ways is to use the onEvent attribute in HTML. And so this is in your actual HTML file. You can just say on, and then the name of the event you care about, in this case, click, and then pass a string. And inside that string, if you write valid JavaScript, it will magically be called whenever the click event happens on this button. Another way that is also really common and even more powerful is the add event listener function. So this is provided on DOM nodes as part of the DOM standard base. So it's provided to JavaScript. And you can call the add event listener function, say the name of the event you care about, in this case click, and then pass a function. And then that function will be called whenever the click event happens on that element. So let's take a look at the onEvent attribute first. We can start out with this button. We're going to tell it that we want to log that the party has started. And let's go ahead and inspect what is in the onClick property when we look up our button out of the DOM. We see that our string JavaScript actually gets parsed into real JavaScript and wrapped in a function call. And whenever that function is called, we're going to get past an event object. And this event object has a lot of really helpful information about where the event came from and a whole bunch of other functions that are really interesting. But what happens if we set that onClick property and just give it a totally different function because we want to? So this time, when we log what is on that onClick property, we see that it is, in fact, our new function. So what do you think happens when we click the button this time? It's the new event listener that gets called. That did update. But you might notice this does mean that we can only have one event listener of each type on a given node when we're working with this onEvent attribute. You can't have multiple. If you try to add a new one, you end up replacing what you had before. And then you can either set in HTML and set or access in JavaScript. Okay, so what about the add event listener function? So in this case, we're going to add an event listener. And what do you think is going to happen when we log the onClick property? Yeah, it's null. That's a totally separate API. You can't use the onClick property to see what event listeners you've attached with the add event listener function. There's actually really no good way when you're doing application programming to actually see what event listeners have been attached using this method. But we can try adding another event listener. So what do you think is going to happen this time when we click the button? That's right. Both of them fired. So when we're using the add event listener function, we can add as many event listeners as we want to any nodes that we want. The only trick is that we can't access them and just sort of like inspect the state of them once they've happened. There are some really helpful tools in your browser when you're working with developer tools that will actually let you inspect and see that. But when you're actually like writing your applications, you just kind of have to fly blind and keep track of it yourself. So can you use both of these event listeners the same? You can, in fact. So we're going to start with a button that has an onClick property added to it. And then we're going to add two more event listeners using add event listener function. So this time when we click the button, all three of these event listeners are going to fire in roughly the order in which they were actually attached. Although I make no guarantees about the order, and you probably shouldn't depend on the exact order that they're firing in. If you're doing like really important things that have to happen in the right order, there's better ways of making sure it happens. But you might have noticed something if you read really closely, which is that when we were actually setting that onClick HTML attribute, we were passing a string with some JavaScript content inside of it. But when we inspected the onClick property, what we actually got back was a function that had the JavaScript itself, like not just like a string, but the fully parsed JavaScript. So why are those different? This is because one of them is an HTML attribute and one is a DOM property, which are remarkably similar but subtly different. So the HTML attributes are always referring to basically what you can add in an HTML file. So it's pretty much always going to be either like a string or a number, whatever you could write as valid HTML, that is the form that an attribute takes. And the first time that your page is actually loaded and the DOM tree is being built, the DOM will actually go ahead and take those attributes and then transform them into properties that have a little bit more state, the way that they want them to be held. So, for example, every time this click event is going to happen on our button, we don't want to have to go parse a string, make sure it's valid JavaScript, wrap it in a function, and then call it. We just want the function. And so that's why the DOM, in addition to giving you references so that you can access those actual HTML attributes the way that you expect them to be, it does also have these special properties that have things in the state that the DOM would really like them to be in. So let's go ahead and take a look at some of this in detail. So we can start out with our party button, and we're just going to go ahead and log the actual attribute. Notice here that we're using the get attribute call, so it's going to get the HTML attribute off this DOM node, and it's just the string, the way that we exactly passed it in the first place. But if we do onClick, now we get the function that has that string parsed into JavaScript in the function body. Okay, so what happens if we set an attribute? Now notice here that we're actually passing a string, not an actual function call, but once again, a string that has JavaScript inside of it. When we log what is in our attribute, it's updated. And when we log what's in the onClick property, it's also updated. So this does stay in sync if you're setting that attribute. The DOM is smart enough to do that. What happens if you set the onClick property directly? So this time when we log our HTML attribute, it's exactly what it was before. That HTML attribute does not get automatically updated whenever you set the DOM property. And when you log the property, it is updated. So which of these is going to win? What's actually going to happen when you click this button? It's the DOM property. So it is helpful to understand the difference between HTML attributes and DOM properties because you can get into some weird behavior between them. But honestly, I really recommend that you just stick with the DOM properties because those are the actual source of truth, and those functions are going to be the ones that are actually getting called. So when we're looking at our DOM node, if we were to actually look at the actual object that we get, from like document lookup, we can see that we have basically an attributes hash that has a whole bunch of strings inside of it, even though it's not actually how it's implemented, and then a whole bunch of DOM properties that translate those into the actual function that we care about. And then somewhere deep inside the browser's own private data where it actually handles all of its implementation for things is going to be this list of event listeners that were added with the add event listener function. So note that we can only reach directly into those things that come from the onEvent attribute. We cannot, with our code, reach into that private list of event listeners, but it is there. So what if we want to start removing these event listeners? How do we do that? When we're working with the things that come from the onEvent listener, it's pretty straightforward. We can just set our property to null, and that will go ahead and null everything out. Note once again that HTML attribute does not get automatically updated, but that's totally fine. We don't really care about it anymore. What about if we want to remove one of the event listeners we added with the add event listener function? Well, it turns out there's this super handy function called remove event listener, and it takes the exact same parameters. This is totally going to work, right? No, it's not going to work. That's because even though these functions look remarkably similar, they're actually two different functions, two different anonymous functions. You have to have the exact function reference in order to remove something from that event listeners list to make sure that you're not deleting other people's event listeners or just like doing malicious bad things. So if we actually want to be able to remove this event listener, what we're going to have to do is keep a reference to it. So one way of doing that is to actually use like the full function syntax, whatever the proper JavaScript name is for that one. We could also still use an anonymous function and then just assign it to a variable. It really doesn't matter as long as you have a reference to it. And then you use that reference to add the event listener, which will go ahead and add it into that list. And then when we call remove event listener, we use the exact same reference and it gets deleted. So when you are working with add event listener, don't use anonymous functions that don't have a reference unless you're absolutely positively sure that you are never, ever, ever going to have to remove that event listener on your own. So just to briefly review what we just talked about, we chatted about the DOM and HTML standards and how those are sort of the rule books that browsers use in order to actually implement all the things that we use in a website. We talked about how we can add events using either the onEvent attribute or add event listener, and we also talked about how to remove event listeners. So we are going to have a super brief GIF intermission. Feel free to stretch, close your eyes, or just sit back and enjoy one of my favorite gifts. I love it so much, it's applicable for every situation. Okay, welcome back. It's time for Act 2. Where do events go? So, event propagation is this process of bubbling events through the DOM. And so it's really how we give parent nodes a chance to respond to events. And this happens by default, and it can be overridden. One quick word of warning here, event propagation happens for pretty much every event. There are some events that don't propagate. For example, I think focus is one of them. But for the most part, everything does propagate. So let's say that we stuck our start the party button inside of a celebration station. And anytime a click happened on celebration station, we want to know about it. So if we click on the start the party button, first its event listener is going to fire, and then its parent's event listener is going to fire. And it makes sense why we want events to propagate by default. Let's say, for example, that we had a button that had an icon inside of it. If our user manages to hit exactly on that icon, we probably still want the button to fire. And we don't want to have to attach the same event listener to the icon and to the button and to anything else that might be inside the button. We kind of want parents to be able to have a chance to respond to things. But not always. So we can just call stopPropagation on the event object that was passed. And this will actually just prevent the event from going anywhere after that. So once again, the parent does not get called there. And if we remember from the last section, the reason that we can call an event like that is because that string with the JavaScript inside of it is wrapped inside of a function, and that gets past the event object when this is actually called, and that stopPropagation is defined by the non-standards. So, I have to make a confession, which is when I told you about the add event listener function, I kind of left off some of the parameters that you can pass. But that's fine, because I'm going to tell you about them now. So, by default, if you don't pass anything as this third option, it defaults to this Boolean that's false, which is really helpful. You know exactly what that means right now, right? This is actually telling the DOM that you want to add an event listener that bubbles. And alternatively, if you either pass a Boolean that's set to true, or an object that has the option capture set to true, you're telling the DOM that what you want to do with this event listener is have it capture. And these words are pretty abstract, but what they are talking about is when, during the life cycle of the event, you actually want this event listener to be fired. So bubbling is the type of event propagation that we just saw, where you start with a child, and the event bubbles its way up through every single parent and gives the parents a chance to respond. Capturing, by default, is where a parent kind of gets a chance to reach in and grab an event before it ever gets to the child. And the easiest way to understand how this works is just to walk through the life cycle of an event. So let's say that we put our start the party button in our DOM tree, and this is all of the parents in the entire DOM tree that are possible. So we're going to go ahead and click this start the party button, and we have an event that's been created called, it's just a click event. And this same event is going to get passed to every single event listener that's called during the life cycle of this event. So we start out in the capturing phase, and we're going to start with this topmost parent in the entire DOM. We're going to see if it has any event listeners that are added onto it that are using capturing, so they have to have that capture flag set. And if so, we'll go ahead and call them with this event object. And then provided that they don't stop propagation, we'll continue down to the next child that's in the path between this topmost ancestor and the target where our event actually started from. And then we'll basically just rinse and repeat the whole way down. So see if it has a capture event listener, fire that. As long as it doesn't stop propagation, go down to the next child, see if that has any capture event listeners, fire those, go down to the next child, see if they have any capture event listeners, fire those, all the way down until we get to the actual target of our event, where the event actually came from. And so now we've entered into the target phase of the event. So we're going to look at every single event listener on our target node, whether or not it's capturing. And then we're going to run all of them in roughly the order in which they were called. We can't make any guarantees that the capture is always going to happen before the bubble when we're in the target phase. It's kind of a free-for-all for events. But once all of those end up getting called on our target node, now we start the bubbling phase. And this is the part that we are probably a little bit more familiar with. And so this is where we go up to our parent, see if it has any bubbling event listeners, fire them, go up to the next parent, look for any bubbling event listeners and fire those, go up to the next parent, look for any bubbling event listeners there, and fire them all the way up to the very top of the entire DOM, looking for any bubbling event listeners and firing those. So one thing that is important to note here is that we kind of start out, go all the way in, and then go back all the way out. And at any point, if any of these event listeners stop propagation, the rest of the event does not continue on. Which means if you stop propagation in the capture phase, you are in for a world of hurt when you're debugging. So, capturing is really cool, and it does give you a chance to kind of like reach and respond to events pretty early on. But honestly, you probably don't need it for most every single use case. You really want to stick with bubbling. If you think about it, it usually makes the most sense to let like the most direct element decide what to do with your events first before passing them on. The times that capturing can be really useful are examples where, say you want to log every single click that ever happens in your application. You might put a capturing event listener pretty high up in the DOM, but you wouldn't want to stop anything. You would just kind of like send it off to your logger. Another case that actually bit me earlier today is if you want to put a focus trap on a modal to make sure that when the modal is open, people can't click outside of it, which is really important for accessibility reasons. What you can do is put a capturing event listener on pretty much like above the dot where that modal is, and then any events that are going to happen outside of it, you can just cancel them and they won't fire. And if you're trying to debug and you're like, why aren't my events firing? That's why. So, what if you do want to go ahead and stop your events? How do you do that? So, the way that you're probably maybe familiar with already, because I've used it once before, is that in your event listener, on the event object that you're passed, you can just call stopPropagation. But what happens if you have another event listener that's defined on that same object? Does it get called? So let's go ahead and start the party. We first log that we have no license to party. The event stops propagation. Well, we party anyway. That's because when we use stopPropagation, what we're really saying is we don't want anything to happen after this node has been handled, but we can go ahead and finish handling any other event listeners that were going to happen on this node anyway. Occasionally, though, you do want to stop immediate propagation. And this time, when we click the Start the Party button, we're going to say that we have no license to party, and then nothing else happens after that, including other event listeners on the same node. So that's kind of your nuclear option. What if I want to use Event-preventDefault? What does that do? So let's say, for example, that our button is actually a button of type submit and it's nested somewhere in a form. Now the browser tries to be really, really helpful in this case. And it says, hey, if you're clicking a submit button inside of a form, I should probably submit the form for you and send a request. Which is great if that's what you want the browser to do, but it's horrible if you don't want the browser to send any requests just because somebody clicked on that button. So in this case, we can use Event-preventDefault on our submit button. And what that's going to do is the event is still going to keep propagating and go through all the different phases. It's just that the browser isn't going to do any default behavior it would normally do when it's handling that event. So in this case, it won't try to submit the form on our behalf. Or for example, if you were working with a link element and you put an href on there, it won't try to follow that link for you. It'll just fire all the click events on that element. So to briefly review this section, stopPropagation will prevent any other event listeners from firing after this node. Stop immediate propagation will do the same thing and also not let any other event listeners on this node happen. And preventDefault lets the regular event propagation flow continue, but it cancels any default behavior the browser would do for this special kind of event. What about returning false? Sometimes event listeners, you'll see the handlers will return false. This is really common in jQuery and some other frameworks where they actually have a definition to say, in our framework and in our way of setting an event handler, if you return false, we'll call stopPropagation and preventDefault for you. But if you've ever tried to do this in default JavaScript, it doesn't do anything. That's because in the DOM standard, event handlers are void functions. They don't respect any return functions at all. So you can return false if you want, but it's not going to do anything with your event propagation. And yes, I have done that. That's me speaking from experience. So I would really say try not to stop propagation when you can, unless you're absolutely certain that nothing else should ever need this event, just because you can get into some really tricky and subtle bugs that are very confusing when events aren't firing, but you really expect them to happen. And there definitely are times when you need to stop propagation, so it's not a horrible tool. Just be careful and know that your future self or your coworkers or the other people working on your side project or the hackathon may get a little bit confused when they don't understand why events that should be firing are firing because you just stopped propagation for things that shouldn't be. So maybe you've been having a little bit too much fun with event listeners and you added a lot, and now your browser is very, very sad. Browsers do get very, very sad if you add a lot of event listeners to them, especially if you're like on an older, slower machine or maybe on a phone. This can't happen. So there's this cool pattern called event delegation, and it's a technique for allowing you to listen for more events using fewer event listeners, which can really improve your performance by using a lot less memory. So let's say, for example, that we have this list of all the different ways that you can have a party, and what we want is that anytime you click on any of these elements, you go ahead and log the type of party. So a really simple way of implementing this is we can just add an event listener to every single one of these that just, like logs whatever the party type is, which will totally work. And as long as we only have 3 types of parties, that's pretty fine. But if we have 3,000 types of parties, or if the number of parties that we're throwing in the types are constantly changing and we're having to add and remove a whole bunch of stuff from the DOM, or this gets really, really nested, it's gonna get really complex. So what we can do instead is just put a single event listener on our list. And then we'll look at the target of our event object, which tells you where the event came from, and then we can decide if we want to handle it. In this case, we'll just print whatever the text content is. So if we click on eat, we get our lovely taco emoji. If we click on dance, we should get our lovely dance emoji. And all of this is happening from the same event listener, which, as a side note, you probably want a little bit more checking in your event listeners, just because let's say you manage to click on the actual list itself, like on the UL element, that click event is still going to fire, but the text content is not going to be what you think it will be. So typically when you actually are doing delegated events, you want to do some sort of checking to figure out where is the event target, is it actually one of the things I care about. But you can see where this uses a lot fewer event listeners. One thing that is pretty cool is if you are using jQuery, I really like the way that they have event delegation set up. So they have this really fun thing where when you're calling .on and attaching an event listener, as your second parameter, you can actually pass a CSS string, like a CSS selector. And so what this does is we're actually setting our event listener on the party central, the entire box there. But then what we're saying is we want to do a delegated event listener, and any elements between the target and the node where we've actually attached our event listener, if they match our CSS selector, which in this case is just looking for list elements, we're going to call that function once for every single one of the events that match, or every single one of the nodes that matches that selector, which is pretty fun. So in this case, it does the exact same thing as before, where if we click on individual list elements, it'll go ahead and log their text content. But this time, if we click on the entire box, that box is not going to match our CSS selector, so the event listener won't be called, which is the exact behavior that we did want. So you don't actually need jQuery in order to do this. I just really like the API that they provide. You could do this in vanilla JavaScript. You just have to do a whole bunch of checking yourself. One thing I will point out is that event delegation, as great as it is really just a pattern and a technique that is taking advantage of event propagation, which means that all the normal rules for event propagation applies, which also means that if you're stopping event propagation before it can actually reach the element where your handler is defined, your delegated event handler isn't going to fire. So this is just even more reason to not stop event propagation unless you're absolutely certain that you need to. And one thing that is really cool about delegated events is that some frameworks, including Ember and I'm pretty sure React, implement custom event handling to give you a lot better performance under the hood. And one of the things that they'll end up doing is they'll put a delegated event listener at the very top of the DOM and then listen for every single possible type of event anywhere in the page, and then delegate it off to your components or any other thing that you care about. So whenever you are writing something that looks like it's going to attach an event listener, it's not actually adding another event listener to the DOM itself. The framework is just keeping track of the function that you want to call and the element this is attached to in its own memory, and then deciding where to call from there. So it can lead to some better performance. It is pretty interesting. I don't recommend trying to do that on your own, in your own applications, just because it can get really complicated. In general, the way that I like to think about delegated events is that the further the element is that's actually handling the events is from where the target, like where the events are happening, it's just gonna get a whole lot more complex really, really fast. So for example, attaching a single event listener to your body element that's going to handle every single click for every single page in your entire application is going to be very complex and very hard to reason about, but attaching an event listener to the top of a list that handles clicks for every single list element is a lot easier to think about and understand and debug and work backwards from. So to review what we chatted about here, we talked about the 3 phases of handling an event: capturing, where we go from the parents down to the child; the target phase, where we handle everything that was on the actual place where the event started from; and then the bubbling phase, where we go from that target element back out to the parents. We talked about the 3 different ways that we can sort of stop propagation or prevent default behavior from the browser. And we also talked about delegated event handlers and how we can use them to have fewer event listeners that handle more events for us. So at this point, you should hopefully feel a lot better about how events work and feel much more confident as you're thinking about how to debug and write your own event listeners. Once again, my name is Marie Chatfield. You can find all the slides for this at mariechatfield.com/talks. And let me know if you have any questions. Thank you. I was serious about the questions, or observations or comments if you want to have them at this time. Seriously, you weren't confused about anything, because I was talking very fast.
Gabe is always confused. We can depend on it.
Stop immediate propagation. What does immediate mean in that context? Because it seems like, right, when it stop just, oh no, but it means like any, right?
Yeah, so it's in
It's
that.
name drop. That's my argument.
I like the name, because to me what it's saying is like bail out now, like take the seatbelt off and like throw yourself out of the car.
Like stop immediately.
Yeah, whereas like stop propagation is more like come to a nice stop in the car, let the other passengers have a chance to exit, like the other event listeners on this node, and like then continue on with your life.
Okay.
Related to that, how does order factor into stop immediate propagation? So, do events happen in the order that you attach them with add event listener?
And they're supposed to.
Okay.
The DOM standard, I'm pretty sure, says, what I'm not certain about is the order between event attributes and add event listener, but in the standard, it did say that when you use add event listener, the listeners should be fired on the node in which the order in which they were attached, which means that if your first event listener calls stop immediate propagation, the rest of them are not going to fire. If your last event listener calls stop immediate propagation, it's not actually going to have any difference between a stop propagation, because there's nothing else left to do. Oh, one thing that would be interesting though is no, that wouldn't work. If you were adding another event listener in an event listener. Oh, does anybody know?
I don't know.
I think it doesn't fire. I think
It doesn't fire? That's probably a good thing. It makes me sad, but more happy than sad, that you can't just like get into an endless loop of like firing more event listeners as part of the
That would be
same.
bad, yeah.
Yeah, that would be bad. You're right. I'm happy that's the case.
It seems like stop immediate creation actually, you should try to avoid using it production, because basically if you're accidentally like inserting another event listener like before or after, we get a very undefined behavior, which
Yeah.
you're gonna scratch your head around already.
I would agree. I feel like stop immediate propagation is probably a little bit too powerful. especially if you're thinking about if you have any other like maybe third-party event listeners that should be firing, especially more towards the top of the DOM and those parents. Like, I can't think of a good example.
Well, one example of emergencies I use the listener is that some operators also also the zero this out the lines also place
Oh, bummer. Why aren't they using a capture event listener?
Yeah, you said it's pretty hard to start debugging all these event listeners. What is there a way to catch if a third-party tool is actually messing with you too much?
Not really.
You can wrap an event listener.
You can define your own event listener, which will hold the appearance of event listener.
The pseudo.
Yeah, so part of the reason that events are so difficult to debug when they aren't behaving the way that you expect is because everything is so asynchronous, right? So it's not like you know what's going to happen next. All you know is you define a function, and at some point in the future, maybe if you're lucky, that function gets called. You don't even, some stack traces in the browser will maybe sometimes be able to tell you sort of like what happened before that. But yeah, for the most part, you just kind of exist in this world where something happened. And that's why passing in that event object is so important, because that does give you some context as to like, where did this event come from? What phase am I in? And a whole bunch of other functions that are pretty cool.
Still know that some problems that I'm having on the events or when I'm looking at third-party dragging about libraries, and you can't debug something, and I just don't know like what is happening. There was a last one that's good, there was a drag, and lots of things happened in between. But I don't know if you've ever debugged third-party dragging about libraries.
I can't speak specifically to drag and drop libraries because I tend to run away from anything that involves drag and drop functionality and make somebody else do it for me. But yeah, in general, third-party libraries that are handling events for you, you're right, it is really hard to debug. At that point is usually when I start going into the source code, just so that I can like try to find a few places where I think event listeners might be happening, and then start trying to put breakpoints in them in my browser's debugger to see if those actually are the events that are firing. Which, by the way, shout out to conditional breakpoints. You can definitely do this in Chrome, and I'm pretty sure you can do it in Firefox. But if you right-click on most of your breakpoint when you're adding them in the inspector, you can add a condition, and it'll only stop if that condition is met. So you can do things like only stop if my event target is like whatever my super fancy button is that I'm doing, and it won't get stopped the 10 other million times that same event is fired. Or, super fun, you can do a conditional that is always false, like doing and false, but console.log, whatever's there, which is a super fun way to add conditional like logging to other people's code without actually having to change it. Sorry, that was a lot of words.
For the breakpoint stuff, you can also set in Chrome anyway what are called event listener breakpoints. So if you've selected like an element, you can, I don't remember the exact like thingy that you click, but basically you can say like break anytime an event listener for a click event, for example, is fired on this element. And it'll stop wherever it is. So this is like huge for debugging all like weird event stuff.
That sounds like a game changer for your third-party libraries.
Yeah.
Or just get rid of dragon.
Do we really need it?
Do you, anyone can answer, but do you know how React works? Because I know like you write like the custom React.
It's like a virtual DOM man and like
Hey, God, get me out of this. Like I know you write like their like custom on click handler that kind of goes to their whatever mojo they do for React Native, React DOM. But I think I heard that it does that event delegation stuff, so everything goes up to the React context.
So I'm going to tell you what I think is happening in React, but I'm going to caveat this, but this is my working hypothesis after working with React for a month and skimming through some of the React docs, plus my knowledge of what goes on in Ember, which have spent a lot of time with Ember. So
Your face got sad there for a second.
no,
Okay.
I love Ember. It's just that like I spent a lot of time reading the source code to understand how some of that was going on. So what I'm pretty sure is happening in React is, for the people that didn't quite follow, what was your name?
Dave.
What Dave was saying is that if you might have noticed when you're working in JSX, if you do on-click and all lowercase, it doesn't actually work. React forces you to do like on-click camel case. That's one of your hints that you're not actually working with real DOM event listeners. Another hint is you're actually passing real functions, not strings, when you're actually doing that there. So React does use synthetic events. So what they're passing into all of your event handlers looks exactly like a regular DOM event because they follow the same DOM event spec, like that standard that we were talking about earlier. And if you want to, you can call event. I think it's native event, and that will give you a copy of the actual true DOM event that was created, but it's just wrapped with a little bit of extra React stuff. And then part of why they're doing that is they are, to my understanding, based on what I saw Dan Abramov say in like some GitHub issue somewhere, is they are actually delegating events. I don't know where the delegated event listener is happening, but it is for performance reasons, and I'm pretty sure that is why you end up with that synthetic event instead of a native DOM event. So I'm pretty sure if you were looking at in Chrome profiling tools, you can see the number of event listeners that are added to your app over time. What you should see, and this is what you see in Ember depending on how you attach events, is that the number of event listeners that are added to the DOM stays pretty static. There might be, say, like 32, if like I think Ember handles 32 different events. The actual JS memory that the app is using, if you're consistently adding more event listeners in React to your page, is going to keep going up because React is storing all of the references, I think, to what should be called, but it's not adding more DOM event listeners unless you're straight up calling like document.getElement.addEventListener.
Okay. So there's some kind of abstraction layer that is doing the delegation, but you don't know if it's happening at React or the component or
It's, yeah, I don't know.
no, and
It's
that's
probably happening at the React root. So like
React,
wherever
yeah.
like where you mount the React tree,
Mhm.
that would be my guess.
If anybody is a React expert and knows.
Well, I came across the persist function that they attach to the event is that say launch to be made available to the rest of your code. And we were like, well, if you don't call persist on that event, what happens to it? Like,
Yeah.
how do you need calls?
I read those same docs.
That's what we look at. Persistent values are kind of, it's not really like set that out.
And when it's saying that events are pooled, what that means is that they don't want to create new event objects every single time an event happens. So they're using the same objects, they're just clearing all the data and reusing them. Like bringing your own grocery bags to the store. Isn't React environmentally friendly?
I'm so thankful that HTML attributes are lowercase because it makes it so easy to remember the React synthetic events.
So two other interesting uses of the capturing at the top of the document are if you're getting super fancy with your JS bundle loading, then a user interaction might occur before the code that's going to handle that has like loaded and executed. And so what some pages will do or apps will do is they'll actually like register a listener at the root that stopPropagation and like builds up an array of like, here are all the events that have happened, and then once the code is actually there, it'll replay them. And so that's one thing that can happen, which is pretty cool.
That's fancy.
It's super fancy.
There's a problem with that because some of us actually require an immediate action,
Yes.
and that
What's an event that requires an immediate action?
like basically the user has some security kind of concerns, so sometimes browsers actually require them to do something in kind of that runtime limited where that might happen.
You're talking about privileged versus unprivileged events?
I
What?
think so.
If you want to spawn a new tab,
Yeah.
it needs to have a certain proximity to the click event. If the browser thinks that it's too decoupled, it just won't. It's like a pop-up box.
Oh, I've totally run into that before. That's what's going on?
You know how you get around that? Less JavaScript entirely. You just like
I thought you were going to say Windows.
delete Windows too. You use IE.
The other thing is even fancier, which is if you have a virtual DOM but in a web worker, then you have to like.
Sorry.
No, I don't have to because Google did it. You can capture all the events and then like send them over to the web worker, and then the web worker like pretends that there's a real DOM there, and then that allows you to run all of your UI code off of the main thread. It doesn't work very well, but it's much faster.
Okay, so to make sure I actually understood that.
Nice
When you said virtual DOM, what you're talking about is when you basically are following the DOM standard yourself, writing your own code to mock out what should you think be happening based on things. You're putting it in a web worker, which is the API that lets you offload things from the main JavaScript thread, is that the right word?
Yep.
By running them kind of in the background, but you can't do a whole bunch of really fancy stuff there because it's just like JavaScript somewhere else.
That's right. You don't
So-
specifically don't have access to the DOM.
Yeah.
You're faking out the DOM in a web worker to figure out what the DOM should do and then coming back to the DOM and just telling it what to do?
Mhm.
Because you think you can write a better browser?
No.
Why would I do it? Why?
There's a couple of good reasons. One reason is for security. So if you do this, then when the changes are made to the DOM, then you have an opportunity to inspect them before they're applied. So for example, if you're running code and say you have a credit card form and some third-party code has gotten in there and it tries to insert an image to evil.com with your credit card number encoded in the URL, you have an opportunity to say like, no, that's not allowed. So that's kind of wonky. Nobody actually wants to do that. The other reason is AMP, and Google has actually built a thing called Workadom to do this now. They want to, in order to provide the guarantees that they like to provide about how quickly the page renders, they basically have to never allow you to run JavaScript because we're all really bad at JavaScript according to Alex Russell and other folks at Google. And so what their solution, they came up to this because everybody's like, great, yeah, but I still want to be able to write JavaScript. And so their solution is to run your JavaScript in the worker so it won't block the main thread. But you can still like manipulate the DOM as long as you stay inside some sort of guardrails.
So the answer is AMP, basically.
Yeah, everybody should be running AMP, isn't that right? Rupert?
It's all your fault, dude. We're gonna have jobs. It's all your fault. You advocate.
Awesome. Well, time check, it is 8:40. I don't know.
Yes.
How-
So let's take a brief bio break. So come back in like 5 minutes, and we can have a discussion about anything else around the web. And then those who want to continue the conversation, we can head down to Walker Street Bar for that. But for now, let's give Marie another round of applause.